draw all the wire and the width. We are going to draw here at z-axis. Start it right from coordinate 0.0, new wire 0.096 1.505 1.496. Okay, each ground plane for 27.355 megahertz. I've calculated is about 2.6 meters. So we are going to draw 4 here. New wire, start it from coordinate 0.000, first ground plane, about 2.6 meter. Okay, and the fourth ground plane started from coordinate 0.0 up to 2.6 meters. Okay, we should accurate them at geometry menu. Okay, the width length 1.5, correct, and ground planes are each 2.6 meters, 2.6, 2.6, 2.6, 2.66. All good. And now we have to input the width and ground planes radius. Radius is half of diameter. Rottmers didn't mention the dimension, so I just take assumption the radius is 0.65 millimeters. 65 millimeters. The overall view would look like this. This is the width, and these are 4 ground planes. And to test the initial SWR, we have to give the pulse. The pulse is inputted at wire 1, which is width at the beginning. That is the join between width and 4 ground planes. W1 stands for wire 1 at the beginning, B at the beginning. Push enter. Okay, now we go to the calculate menu. Frequency 27.3555 355, I mean, right? And it is not, the antenna is not going to be put at free space. No, certainly. Perfect, no. But it's going to be realized at a real condition at the top of car roof. And Rottmers mentioned that He's going to use mostly at suburbs at Australia. So we should set the ground setup here to put the dielectric and conductivity values. Where to get these values? You have to see the MMANA manual. There are several options. I think the most appropriate um, match the condition, or most likely the condition is dry field forest. Okay, the value for the electric constant is 13 and conductivity is 5. So we put 13 and 5 here already, right? Click OK. And Rod said that his car roof height is about 1.65 meters above the ground. So already 1.65 meters here, right? And the material of the whip, Rod said, made from stainless metal. So I think the most appropriate material here is probably ferrum pipe here. Okay, ferrum pipe. Okay, after all conditions correct, so we start the initial SWR simulation. Okay, you see here the SWR is 220.80. Of course, this is far from ideal because the good SWR is 1, and read as real impedance, this is read as 12.26 ohms minus J 364.31 ohms. This is a resistant part of the impedance, and this is reactance part of the impedance. The ideal impedance reading should be 50 plus minus J0, okay, minus J 364.31 means this antenna has capacitive characteristic too short. Okay, of course too short. You know that most of mobile antenna made shorter than the ideal quarter wavelength condition. Okay, and to compensate to reach minus plus J0 should be compensated by loading coil. Okay, click the options and setup menu here and resonance tab. Okay, and you see here, this is the calculator to to calculate the compensating loading coil for this capacitive characteristic of this antenna. Okay, the frequency already inputted right, 27.355 megahertz, and the reactance, this is not correct. The reactance is 364.31. Okay, so you should correct here 364 364.31. Okay, ohm. And you should see here the compensating L should be 2.12. Not ohm, this is wrong program by the programmer. The unit here should be micro henries. Okay, 2.12. Okay, 2.12. Now you should back to geometry. We are going to add compensating loading coils, which is base loading coil located at the little bit up from feed point. So you should write down the variable here. W1B stands for wire 1 at the beginning, and 1 again means one step up from the beginning of wire 1. Just one step up, not too far, because this is base loading coil. You could see how to utilize this variable at the manual. Click enter. We are going to put the already calculated value, which is 2.12. Enter. And the average Q or quality factor is 300. Just put 300 here. And now click again calculate. Start simulation. You see here the SWR already lowering, but not enough. You see here the reactance already reducing, only J 6.53, but it is not enough because the ideal reactance is plus minus J0. So you have to add the loading coil value. Go again to the geometry menu, and let's try 2.16 here. 16, enter. Click calculate, click start. You see here now the reactance is plus J 0.41. This is a good value, very close to plus minus J0. Means that this antenna already at resonant condition. But the resistance still not good value because this is still 14.06. The proper value is 50 ohm. So now we have to calculate what is called matching system to make this value up to 50 ohms. Just click the options menu here, click LC match. there are two kinds of LC match systems. First is C parallel with coaxial cable, and the other one is C series with coaxial cable. I prefer use C parallel, and you should check the input impedance here, because you are going to use RG58 coaxial cable, so the characteristic impedance is 50 ohm. This is already right, 50 ohm. And the output should be 14.06, right, and 0.41, right, already. So the calculated values for this matching system, capacitor is 186.1 picofarads, and matching coil is 0.13 microhenry. This line connected to the inner of coaxial cable, and this line connected to braid or outer of coaxial cable. This line goes or continued to ground, which is unpainted part of your car body. Okay, ground planes not necessary, and this line goes to the matching coil and continued instantly directly to the loading coil here. You could join or gather these two coils together.